Welcome to Study Loop.
So here we're given a lot of information about polonium. We're going to use this information to calculate Avogadro's number. So polonium crystallizes into a simple cubic cell. Its density is 9.3 grams per cubic centimeter. The radius of a polonium atom is 167 picometers. And the molar mass of polonium is 209 grams per mole. And we want to know Avogadro's number, which we know already is in terms of atoms per mole. So we need to take our conversion factors and our information that are listed here and use them to get to atoms per mole, is sort of the gist of what we're getting at here. So we need to use what we've been given to get as much information out of this as we can. So because we know this is a simple cubic cell, we know that there's only going to be one polonium atom per unit cell. And it also means that the edge length of this cell is simply 2 times the radius of polonium, which means that our edge length here is going to be 2 times 167, which is 334 picometers. Now we just take this number and cube it to get the area of the cell. And if we do that while converting it into centimeters, we find that the area of this cell is 3.726 times 10 to the negative 23rd centimeters cubed. Now remember that the conversion factor between picometers and centimeters is just taking this and multiplying it by a factor of 10 to the negative 10th. So now that we know the area of this unit cell and all of the information listed above, we can go through a pretty straightforward conversion to get this into terms of atoms per mole. So we already know the molar mass of polonium is 209 grams per mole. So we're already halfway in terms of getting our units on top and bottom to match up with Avogadro's number. We're already halfway there with the molar mass. So we just need to convert ourselves from grams to atoms. So to do this, we're going to use these conversion factors to our advantage. So the next thing we're going to get to convert us from grams into terms of our unit cell is the density. So we're going to take our density and throw that in at this point. So we get 9.3 grams per cubic centimeter. We also just determined that per unit cell, we have 3.726 times 10 to the negative 23rd cubic centimeters. And we know, this is just a formality at this point, that since we have one atom per cell, we cancel out the units that we have set up here. We are now in terms of atoms per mole. And lo and behold, if we calculate this through, we get 6.04 times 10 to the 23rd atoms per mole, which is very, very close to the 6.022 times 10 to the 23rd that we're all very familiar with.